Okay, so Newton's second law said that when we have a resultant force or net force, net force has any value, maksudnya macam ni, W, let's say 20 lah, 20 Newton. So 20 Newton, the resultant force, pada hanya satu saja, so resultant force is 20 Newton. The mass, tadi mass yang sama, 2 kg. The 2 kg mass will fall with an acceleration. And we can calculate the acceleration by using F equals to ma. So the acceleration is 10 meter per second per second. Okay, so this one is actually recall back lah kita punya tajuk yang force and motion 1. Okay, when the resultant force is 0 and when the resultant force has a value, okay, if the resultant force is 0, the object will either, macam tadilah kita letak objek atas surface, the object will either be stationary or can the object move if the resultant force is 0? Can an object with 0 resultant force move? Can anybody respond?
Yes, with constant velocity.
Yes. Okay. When an object is at 0 resultant force, it can still move, but the movement is a constant velocity. Okay, so constant velocity, when an object moves with constant velocity, what is the acceleration?
0.
0. Okay, so stationary, 0 acceleration. Constant velocity also have 0 acceleration. Therefore, object with resultant force of 0 Newton can be either stationary or constant velocity. Okay, but when an object has a value of resultant force, example, you have two forces that is not equal, opposite direction, or two forces same direction, okay, it will give you a value of resultant force. That object will move with acceleration in the direction of resultant force. Okay, example, we have one object being pushed with a 2 Newton force and the other one pulled with another 2 Newton force, and the object is 2 kg. Okay, can someone give me what happened to the object, and if it moved, give me the velocity or the acceleration of the object. So what will happen to the object? Yes. Move to the right. Kalau boleh kan, onkan mic cakap, sebab bila saya present, I cannot see the chat room. So I kena pergi chat room, I buka balik. Okay, so it move to the right. Okay, dia akan move to the right with 2 meter per second with acceleration 2 meter per second per second. Okay, so how do we get the 2 meter per second per second? So what are the steps that we must do in order for us to get the acceleration? Mula-mula kita buat apa?
Calculate the resultant force.
Yes, we calculate the resultant force. These two forces kita need to calculate. 2 Newton plus 2 Newton. And the direction are the same, so we don't need to put negative sign. Negative sign only when opposite direction. Okay, so we get 4 Newton. So this is the resultant force, and according to Newton's second law, resultant force will cause a mass to accelerate. So resultant force for Newton, and the mass is 2 kg. So the acceleration is 2 meter per second per second. Okay, very good. So another example, we have an aeroplane. Okay, the aeroplane is moving with velocity 2 meter per second, but it is descending with uh, with an acceleration of 1 meter per second per second. Okay, so what can you say about the forces acting on the aeroplane? How many forces, which direction, and what are the relationship between the forces? Okay, anybody? Ada sesiapa yang nak volunteer untuk explain?
Teacher, for the V there is
Mhm.
velocity or acceleration.
V is velocity.
But why the unit for the velocity is
Tertinggal.
acceleration?
Salah. Okay. -1. Okay. So, can someone explain uh, direction of forces? Ada berapa forces acting on it? What are the direction of forces? And what are the relationship between these forces based on the motion of the aeroplane? Okay, anybody? 4E? 4E pula. 5E? Anybody from 5E want to respond? Oh, saya belum perkenalkan diri untuk 5E. I am Puan Rita Laili. I will be taking over your class from Cik Safira for the whole year lah sampai SPM. Okay, so so anybody from 5E want to try and answer? Firstly, ada berapa forces? Yes.
Three
Um,
for
yeah, where when?
gravitational acceleration and velocity.
Gravitational, acceleration and velocity. Acceleration and velocity is not forces here.
So weight.
Yes.
Weight.
Weight. Okay, weight. We know that weight is a downward force. Okay, weight. And then, how many forces? Tadi saya nampak ada answer Sutarshini, 4. And then Karishma said 3 forces.
Sure, there's also air resistance, right?
Okay, we have resistance. Which direction is the resistance?
Opposite of the velocity.
Okay, if the object is moving to the right, resistance is opposite direction. So we have resistance, or some might say friction. So what is the name of the force going forward for a moving object? Kita panggil dia apa? Biasanya pada kenderaan lah. Kita panggil apa? Force yang moving forward. Apa agaknya?
Linear motion.
Linear motion is moving straight line. Linear motion is not a type of force. I hope you try and answer, and if your answer is wrong, don't be disappointed or embarrassed, because we learn from mistake better than when we are right all the time. Okay. So tadi apa? Kinetic force. Kinetic is not a type force, sayang.
Teacher,
Kinetic
is
is a
it
type of
just normal
energy.
force?
Yeah.
Is it just normal force or forward force?
Okay. Normal force tadi saya sebut exerted by a surface. Ada surface tak kat sini? Are there any
Okay.
surface here? No surface kan? So there is no normal force.
Is it resultant force?
Resultant force is the net force. When you add all the forces, baru dapat resultant force. So sekarang saya nak tahu apa forces yang ada. So sini sebut normal, weight, air resistant, force acted by the plane. Okay. So force acted by the plane is called thrust. Pernah dengar engine thrust? Okay, so engine force actually. Force produced by the engine. So thrust. Okay, making the object going forward. And one more. Nah, yang ni ramai tak dapat jawab lagi. Weight dah ada, friction dah ada, engine force dah ada, which is thrust. The other one, going up. Nama dia apa? Dia bukan normal. Normal is only when object is placed on a surface. Tapi sekarang tak ada surface.
Actually,
Yeah.
lift.
Yes? Lift. Okay. So the force is known as lifting force. Okay, sebab tu bila flight nak naik, dia cakap nak lift off. So it is called a lifting force. Okay, so there are 4 forces acting on the aeroplane. Okay, now what are the relationship between the forces that are parallel? Yang parallel saja between resistance dengan thrust, lifting dengan weight. So what is the relationship? Resistance dengan thrust. What is the relationship? When the question asks you relationship, you have to give either when the thing that you need to relate is only 2, you need to explain whether one is bigger than the other one, or it is equal. Okay, kalau ada 2. Tapi kalau ada 3, relationship biasanya involve apa pengiraan lah ataupun formula. Okay, so since there are only 2 parallel forces, so what are the relationship between force, thrust and resistance? Thrust is bigger than air resistance. Okay, sorry, mana tadi pergi? Okay, kejap. Thrust is bigger than air resistance. So sini. Setuju tak? Thrust is bigger than resistance. What about everybody? Setuju tak? Do you agree that the thrust is bigger than resistance?
The thrust must be bigger than the resistors or else the plane cannot fly.
Are you sure?
Because the plane need to overcome the air resistance only we can move forward.
Oh, teacher.
You have to focus on the situation here. The situation that I'm giving here.
Teacher, is it because the thrust is constant velocity, so it must be equal?
Yes, okay. You have to look at the question. When you receive question, jangan terlalu fikir terlalu jauh sangat. Focus on the question. Okay, kadang-kadang nampak macam tak logik je. Tapi actually, when the aeroplane is on the air, dia boleh move constant velocity. Tak ada masalah. Okay, so the thrust and the resistance is equal. Why is it equal? Because it is moving with constant velocity. How do we know that it is moving with constant velocity? Because it is written here, V equals 2 meter per second. Bila dia hanya bagi velocity, maksudnya dia bagi tahu that the velocity is constant. Okay, boleh? Okay, can you
Boleh.
understand that? Yeah,
Can.
R equals to T. Okay. When the resistance is higher, thrust force is less. Yes, but in this condition, the thrust is equal to resistance. How do we know that it is equal? Because it is moving with constant velocity. Okay, kalau awak ingat tadi, kita kita cakap where resultant force is zero, it can be either stationary or constant velocity. How to get zero resultant force? Two forces opposite direction that is equal. Okay. What about the two forces opposite direction vertically? What is the relationship between lifting force and weight?
The
Yes.
weight is bigger than the lifting force because
Okay,
the
the weight.
acceleration is bigger.
Yes. Okay.
So
So based on the situation here, the weight is bigger than the lifting force. Why? Because the object is accelerating downward. Okay, how do we know which one is big and which one is bigger? Look at the direction of acceleration. Okay, if you look at the notes that I gave earlier, when the resultant force has value, it will move with acceleration with the direction of resultant force. Okay, and the bigger force will produce the resultant at its force. At its direction. Okay. So this one, boleh follow?
yes,
Okay. So the next one is perkara yang perlu awak ingat sangat-sangat to get resultant force or to calculate resultant force, kita combine parallel forces sahaja. Okay. To calculate the resultant force, you only take into consideration the forces that are parallel. Macam kereta api ni, kereta api pula, kapal terbang ni, kita tak campur thrust dengan lifting. Kita tak campur thrust dengan weight. Kita tak campur resistance dengan weight. Okay, because they are not parallel. Okay, so to get resultant force, we only combine parallel forces. Okay, but macam mana pula kalau we have an object and the force is like this? Macam we have a bag, we pull like this. What about this? Kita tahu the bag have a weight. Okay, but the force is not parallel to the weight. How do we calculate the resultant force?
we need to
Sedang,
resolve the force that is moving upwards.
okay, we need to calculate the force that is moving upward. Okay, we know that we have normal force, but we have another one, another extra force. Let's say this force is 2 Newton, and the object is 20 kg. Okay, so we have two forces, normal force. So 20 kg pula. Hold on. Let's say this is 4 Newton. Okay, and the force acting at an angle like this is 2 Newton, and the force is acted on the object at, let's say, 30 degree from the surface. Okay, macam ni lah. We have a bat and then we pull like this. So how do we calculate? Sedangkan we know that to calculate resultant force, we only can calculate parallel forces. Okay, so since the object is placed on a surface, ya ada normal force. Yang normal force ni kita tak fokus sangat. Kita nak yang tu, kita nak yang ini. Okay, we want to know what will happen to the back. Okay, for a force that is exerted on an object at an angle, maksudnya bukan vertically, bukan horizontally, but it make an angle with the surface. For this one, we can apalah rayaan daya, we can split the force into two perpendicular forces, okay, which is called, saya tak ingat, nanti saya tengok apa dia punya term in English.
Resolution of force.
Resolution of force, sorry. Okay, so the force can be resolved into two forces perpendicularly. One is parallel to the surface, the other one is vertical or perpendicular to the surface. Okay. Kenapa tak boleh? Okay. So the force yang make an angle with a surface or make an angle vertically or horizontally can be resolved into two components. Okay, one component is parallel to the surface, the other one is vertical or 90 degree to the surface. Okay. But before we continue with this, we have to look at force as vector. Form 4 pula, maths, awak ada belajar topik vector kan? Ada tak?
At maths.
At maths, ada belajar vector kan? What are the characteristic of vector? Vector mesti ada direction, mesti ada magnitude. Let's say I have 2 Newton and I move this 2 Newton here. Okay, so these two forces or these two vector are the same. Betul tak? Yes?
Yeah.
Kan? Vector, as long as direction the same, value the same, is considered as the same vector. Betul?
Yes.
And we can move the vector anywhere as long as we did not change the direction, as long as we did not change the value. Okay, it's still considered the same vector. Okay. So, here, to calculate the forces that to calculate the force that act on the object, untuk force yang buat angle ni, kita boleh pecah kepada dua komponen. Okay, one perpendicular and the other one is parallel to the surface. And how do we calculate the component? We use Pythagoras theorem. Okay, Pythagoras theorem yang sohkah tua tu, ada guna tak sohkah tua for triangle?
Yes, sir.
Yes, okay. So, ni sebab diagram saya tak tepat, I draw satu lagi. Tadi berapa? 2 Newton. And the angle is 30. Okay, and then kita boleh pecah dia kepada 2. And this force ini boleh pindah kat sini. Okay, force yang ini can move here. Betul? Okay, so let's say this is y, and this is fx. Okay, so we can calculate either fy or fx using Pythagoras theorem. Fy, bila kita pindahkan, as long as the direction is the same and kita kata value is the same uh, force. So using Pythagoras theorem, kalau nak cari Fy, Fy is opposite. So it should be sine, sine pula. Macam mana? Sine 30 is, yeah. Sine 30 equals to opposite divided by hypotenuse. Kan? So Fy equals to 2 Newton sine 30. So we can calculate Fy. So formula is F, which is dalam case ini is 2 Newton sine 30 using the Pythagoras theorem. Whereas for Fx, we can use Pythagoras theorem also, tapi sekarang Fx is ascending apa? A kan? Adjacent. So kita gunakan cos. So F cos 30. Okay. Kalau masa saya ajar bahasa Melayu, saya ajar dekat budak-budak saya, kalau komponen yang kita nak cari tu exactly next to the angle, which is Fx betul-betul sebelah angle, dia kawan. Whereas Fy tu dia jauh dari angle, dia setan. So to remember lah which one, sin ke cos ke. So dekat kawan, jauh setan. Masa saya ajar bahasa Melayu lah. But now kalau nak guna any formula untuk senang ingat, boleh guna. But how do we get this is by using Pythagoras theorem. Okay. So if you look here, the 2 Newton can be resolved into two forces, okay, which is Fx, kita panggil dia Fx, Fy. Saya tak suka bagi nama Fx, Sy ni because sometimes the forces dia boleh pusing. So bila pusing nanti you confuse. But kalau tengok dekat dalam buku dia memang guna Fx, Fy. Okay. So using the formula F dekat kan, so kawan cos 30. So 2 cos 30. And then this one is F jauh setan sin 30. So 2 sin 30. So this one you get, what is the value for the horizontal component?
1.
1. Whereas for the horizontal 1. Untuk vertical?
1.732.
1.7
32.
3.
32.
3 or apa tadi? Tak dengar.
Okay. Correct. 1.732.
Oh, 1.733. Okay, 1.73. Okay, so bila kita dah pecah, after we resolve the force into two component, kita boleh calculate resultant force. Tapi untuk calculate resultant force, we only take the parallel forces. Yang ini dengan ini. Okay, and then yang ini dengan any horizontal forces. Okay, so horizontal dengan horizontal, vertical dengan vertical. Horizontal tak boleh combine dengan vertical. Tak boleh campur directly lah. Okay. So this is one method. Yes.
Right, sir. For the FY, right, sir, the vertical one,
Uh-huh.
the 2 sin 60, right? Oh no, no, it's 2 sine 30 times. The answer,
FY 2 sin 30. Macam mana tadi? Tak dengar sangat. Type dekat chat lah. Tak dengar pula. Saya tengok dekat chat. Oh, okay. Okay, so this is one method for us to calculate forces that is not parallel. Okay, the other one is using resolution force. So force kita resolve kan. Okay, the other one is using parallelogram. Okay, let's say we have a boat and the boat is pulled by two small boats. Let's say this one is 2 Newton. This one is 4 Newton. Kenapa tu lagi panjang daripada 4? Terbalik. So let's say this is 4 Newton. This is 3 Newton. Okay, and the two forces is being pulled at 30 degree. Okay. This one is very hard for us to resolve because we don't know what is the angle. Sebab angle dia 30 kan. So tak boleh lah tulis tengah-tengah ni letak macam tu and then we anggap this one is 15, this one is 15. Tak boleh because the forces are not equal. So dia akan lebih besar daripada satu. So for this type of question, we cannot use resolution of force. What we should do is we should draw using scale. So let's say we use the scale 1 cm is equal to 1 Newton. So when we draw this one 4 cm and this one 3 cm. Okay, so we know that 1 cm is equivalent to 1 Newton. And then we know that characteristic of vector is you can change the position as long as you did not change the direction, you did not change the value. So you draw another 4 Newton or 4 cm line that is parallel to the original 4 Newton. Okay, and then another line that is the same direction as the 3 Newton with the same length. So we have here 3 Newton, 4 Newton. So that is why it is called parallelogram, because we are moving or we are drawing or we are shifting the force parallelly. Okay. So for the resultant force, dia simple saja for parallelogram is from the initial or the boat position ke point di mana mereka bertemu. Since we are drawing this with a scale where 1 cm is 1 Newton, we measure the length. Let's say the length is 6 cm, contohlah. So what is the resultant force then?
6 Newton.
Yes, 6 Newton. Okay. So we have looked into resultant force. Okay, if the forces are parallel. The other one, if the forces are at an angle with each other or with a surface. Okay, so we stop here, and for our next class on Tuesday, I'm going to give you homework after this. I want you to try and answer. And for our next class, I want those whom I call out give your answer or share your answer. Boleh? So semua orang kena buat. So bila seorang share answer, you check your answer whether your answer is correct or not. Okay, class?
Okay, Chair.
Okay.
Okay. So later for 5E, I am going to share with you the Google Classroom code so that you can get the question from there. Ataupun I share in the WhatsApp pun boleh jugalah. Okay, but I'm going to form a class in Google Classroom for 5E. Okay, so I stop here. So hopefully we are going to see you on Tuesday berapa lah? Bila? 12 to 1 kan?
Yes, Chair.
Okay. So I'm going to see you again on Tuesday 12 to 1. Okay, so bye.
Thank you, teacher.
Okay.
Thank you, Chair.